Hello Junior 4, let's start concept 3 in theme 3, which is talking about the renewable energy resources. So tell me, what are the renewable energy resources from the previous lesson? Yes, the renewable energy resources are solar energy from the sun, wind energy, and water energy. Okay, and we took them before in the previous lesson, and we all know that we use the renewable energy resources to produce or generate electricity. For example, here in the solar energy, we use a device called solar panels. And the wind energy, we use device, it's new, which is called wind turbines or windmills. Wind turbines or windmills or turbines. And also water, we can use high dams or dams and waterfalls to generate electricity, and we can also use water mills or water turbines. So we are going to talk about them in details in this lesson and their history. Let's start first with the windmills and water mills and their history. Long ago, about 100 years ago, before discovering electricity, people needed machines to make their lives easier. So they used windmills and water mills to help them grind grains to make flour. Grain like the wheat, like the corn, all of these we call them grains. Okay, so they have to grind them. Grind means crush. Grind means crush to make flour. Okay, so long ago, old people or ancient people, they used the windmills and water mills to grind grains to make flour, not for generating electricity. Like here, let's start with the windmills. The wind movement generates kinetic energy, and this kinetic energy causing the movement of mills blades, and leads to movement of kinetic energy to other parts of the mill to grind the grain. So it has another part to grind or crush the grain. Instead of grinding them by their hands, they use the energy from the wind. From the advantages, remember the advantages means good or bad, good things. From the advantages of the windmills, they are low cost, they are cheap, okay, and also they are renewable energy resources. But think with me, what can be the disadvantages of the windmills? Does it blow wind all the time? No. So when the wind doesn't blow, the windmills will not move, so they are unable to do their job. So that's a bad thing about the windmills. Okay, by the way, that's the old windmills here. That's the old windmills that they use it in grinding grains and forming or making flour. Let's talk about the water mills. Water mills also, they take the water movements that generate what? Yes, excellent. The water movement generates kinetic energy, causing the movement of the mill's blades, leads to movement of kinetic energy to the other parts of the mill to grind the grain. So after moving the blades, they are connected to other part. This part that when moves, it grinds the grains. Also, the advantages of water mills, it has low cost, means cheap, and it's a renewable energy resource. But from the disadvantage of the water mills, what will happen if the water supply dries up? The water mill doesn't move, so they are unable to do their job. So here The disadvantage of the windmills, if there is no wind, it cannot do its job. Here, the disadvantage of water mills, if there is no water supply, the water mill doesn't move. Okay, you have to note that both old windmills and modern windmills or turbines are used to generate electricity, but they differ in shape and number of blades. Like here, the old windmills, it has 4 blades, and the modern windmills or new windmills or turbines, it has 3 blades. So they are different in the number of blades, but both of them, they are used to generate electricity. With me these questions, put right or wrong. Hundreds of years ago, people used windmills and water mills to grind grain to make flour. Is it right or wrong? Yes, right. All mills depend on kinetic energy of wind only in order to be operated. All mills? No, we have 2 types of mills, windmills and water mills. So they depend on water and wind. So it's wrong. Number 3, from the advantages of windmills and water mills is that they are low cost. Advantages, yes. Number 4, the kinetic energy of water is responsible for movement of windmills. The kinetic energy of water, of course, not. The kinetic energy of wind. Or instead of writing windmills, we can write water mills. Here are some examples of renewable and non-renewable energy resources. Like here, let's start with the flashlight. What is the energy resource for the flashlight? Yes, battery. Is it renewable or non-renewable? Non-renewable. Once the battery is finished, we will replace it. What about the car engine? What is the energy resource of the car engine? Gasoline. Is it renewable? No, it's non-renewable. What about the fan, the electric fan? What is the input energy for the electric fan? Yes, electrical energy. From where do we get the electrical energy? From the electric power stations. So what do we use in the electric power stations here? Yes, excellent. We use coal, which is what? Non-renewable energy resource. What about the stove or the gas oven? We use natural gas, which is also non-renewable. And the last here, this lightning lamp. Can you see what is the source of energy that this lightning lamp is using? Yes, this lightning lamp uses solar panels using the sunlight, which is what? Renewable. So now let's talk about some facts of the sun and as a solar energy or as a source of renewable energy. Do you have to know that the sun, it's not a planet. The sun is a star. Do you know that? Yes, it's a star, but it's the closest star to us. That's why we saw it very big compared to the other stars in the space. So the sun is a star that consists of gases mostly. These gases, we call them hydrogen and helium gases. Again, repeat after me. Hydrogen, helium gases. Hydrogen and helium. So the sun is made up of 2 gases. These gases, or mostly these 2 gases, which are hydrogen and helium. But is it solid? Does it have a solid surface like the Earth or the Moon? No, the sun doesn't have a solid or a hard surface like the Moon, but it has a surface of gases. We call this surface of the sun photosphere. We call it what? Photosphere. The photosphere is the gas layer at the surface of the sun where the light we see is emitted. Emitted means sent or given from the sun. Now, how does the sun produce light and heat? The energy of the sun comes when hydrogen and helium gases in the sun react at very high temperatures. React means combines. The act means combines together at a very high temperature, producing a huge amount of light and heat. Now, light and heat travel through the space in the form of what? Remember the sound waves? Yes, the same. So they travel in the space in the form of waves. So the light and heat travel through space in the form of waves. Some of these waves reach the earth, not all of them. Because the atmosphere, the air or the air that surrounds the earth absorbs the energy of the sun. Not all of it, but you have to know, very important note, you shouldn't look directly at the sun, as its rays are too strong and too dangerous and can harm your eyes. So you shouldn't or you mustn't look at the sun directly with your eyes. You have to wear special glasses, or you have to always put a medical sunglasses if you are looking at the sun or if you are exposing to the sunlight for a long time. So because these rays are very bad. The atmosphere of the earth sometimes absorb some of this energy, but not all of it. And the land and water on Earth's surface absorb the energy of the sun, which causes a rise in Earth's temperature. Now, let's have another question. How does the energy of the sun reach us on Earth? We said they travel through waves, but we are going to call the energy that reaches the Earth or that travels through space a different way. We all know that we call the energy from the sun is the solar energy. So the solar energy of the sun comes from the sun. We call this energy radiant light. We call it what? Radiant light and heat from the sun. So this energy, radiant means shining or glowing. That's why because they travel in the space, we call them radiant light and heat from the sun. So now we have a different names of the solar energy, which is called radiant energy. The solar energy contains a type of energy called radiant energy or radiation, which is found in the sun rays. Because they are glowing and shining, we call them radiant energy. Now let's talk about uses of the solar energy. We have many uses of the solar energy. Direct source of thermal energy. We use it as a direct source of thermal energy. We use it in something called greenhouses. We will understand what is the greenhouses. In warming houses and in cooking food and also in heating water. Let's start with the direct source of thermal energy. Solar energy can be used directly as a source of thermal energy when exposing yourself to the sun to feel warm. So if you want to feel warm, we will use the thermal energy of the sun to feel warm. Here in the greenhouses allow the solar energy to enter. These houses are built for plants. Help the farmers to plant crops that only grow in warm climates. So, in the greenhouses, they allow the solar energy to enter, especially which energy? Radiant energy. This question comes complete. This radiant energy is converted into thermal energy that warms the inside of the greenhouses. The thermal energy helps farmers again to plant the crops, the fruits and vegetables that only grow in warm climates. Number 3, in warming houses. Houses can be built in a way that enables the energy of the sun to warm them. This happens by placing here large windows on the walls that face the sun for most of the day. Number 4, we use it in cooking food. We use a curved mirrors, you know, the mirrors that have a smooth reflecting surface. We put or use it to heat or use the sun rays to heat the metal pots because it reflects the sun rays, and we use it to heat the metal pots and cook the food inside. Number 5, in heating water, panels of the solar panels made of black pipes are placed on the roof of houses to heat the water, and when it passes through the pipes by absorbing the thermal energy from the sunlight, then the heated water is stored in a tank. This is the tank to be used later. Now let's talk about the solar panels in details. Solar panels can be either very small to supply only one light bulb, like we saw in the lightning lamp, or very large to supply buildings or cities with energy. How do solar panels work? Solar panels are composed of many small solar cells. These cells capture means take or catch the solar energy, especially radiant energy, and convert it into electrical or thermal, like here in the heating water tank. Most solar panels are used to generate electricity. Here, electricity generated by solar panels is used in or to light up the streets. Number 2, to recharge some types of batteries, like here in calculators with the small solar cells. Can you see him here? You all know, maybe saw this calculator before. It works with the solar panel that has some solar cells. Also in houses to operate various or different electric devices, and in some villages, places where farmers can live, to operate some irrigation equipment. Irrigation means providing the plants or the crops with water, so they use the solar panels to operate these devices or equipment. Now let's talk about using energy of the wind. We already talked about the windmills, but let's talk about it in details. We can use the wind to generate electricity by changing the kinetic energy into electric energy by windmills. But we all know that the main source of all energies is what? The sun. Even the sun could be the main source of the energy of the wind. Yes, radiant energy from the sun heat up the air to different degrees. Now we have two different air. The difference in temperature between the cold and hot air causes air to move and wind blow. Now the kinetic energy of the wind movement is used to rotate, to make it revolve or turn around the blades of the turbines in the windmills, generating electricity from kinetic energy then into electric energy. Now electricity passes through huge wires in power stations to different places such as houses and factories. So, what are the factors affecting the efficiency of wind turbines? Efficiency means the quality of its job. There are three factors affecting the efficiency of the wind turbines. Number 1, the number of blades. The number of blades, when they are decreases, for example here, remember the old has 4 and the modern has three blades. When they decrease, they rotate faster. So the efficiency of wind turbines increases. So when decrease the number of blades, decrease their number, the efficiency increases. Number two, the kinetic energy of wind, the speed of wind. If the kinetic energy of the wind increases, the blades rotate faster. So if the kinetic energy here increases, the blades rotate faster, so the efficiency of wind turbines increases. And also the direction of wind. We have two types or two direction. When the wind blows from the side of the wind turbines, here we have the wind turbines, and the wind blows from its side, this of course makes the blades rotate faster, so the efficiency increases. When the wind blows from the front, here from the front, the blades rotate slower, so the efficiency of wind decreases. Wind turbines are used in places with strong winds. Here the energy chain of wind turbines start with the sun, but radiant energy converted into heat energy. The difference between the heat or hot air and cold air generates wind or make the wind blows and change or converted into kinetic energy, and this kinetic energy is changed into electrical energy by the generator. Now, how can electricity be generated from dams using water turbines? Let's talk about the water energy. We can use water to generate electricity by also changing kinetic energy into electric energy by water turbines by the help of dams. Rivers flow downhill like this, like the waterfalls, changing the gravitational potential energy of water into kinetic energy because it has a potential energy at the top of the hill. When the water falls, all of this potential energy changes into kinetic energy. Dams are built on rivers to prevent the flow of water, so the potential energy here increases or decreases. If we build dam here, yes, increases. So here we build a dam which has height, the potential energy increases. Here when the water is released, it flows through the water turbines in dams. Here when the water released, make or causing the rotation of the water turbines and generating electric energy, generate kinetic energy changes into electric energy. This electricity, we call it hydroelectricity or hydroelectric energy, is sent through the long electric wires to different places. Hydroelectric energy or hydroelectricity, it's a type of electric energy generated by water turbines in dams. But we all know that the water is renewable energy resource. How it's renewable? Here we are going to study the water cycle. Can you see here in this picture? The water cycle, the water returns again to the river, but not through its way, through the dam, but it flows into other bodies like lakes, streams, and so on. How this happen? The water will evaporate because of the high temperature. The water will evaporate, change into vapor, changes into gas. You know the water vapor? Yes, it changes into water vapor. This water vapor change and dries up and form the clouds by condensing. Again, evaporates means change from water here, change from water into a vapor gas. This vapor gas will rise up and condense, forming clouds. Condenses forming clouds. Clouds means, or condenses means, changing from this water vapor into water that forms after that the rain. So again, water evaporates, forming cloud, condensation, then what the rain form again. Okay, then when the rain form, it will fall into the lakes and so on, and different parts. Those clouds, the water returns again to the rivers. Water turbines are used in places where dams are built or on rivers. Thank you, Junior 4. That's the end of concept 3 in theme 3.